Glycolysis, like it says up there, is the first step. Sorry. In the breakdown of glucose. Because ultimately, what are we making this into? Carbon dioxide and water, right? Breaking something big into something small. Sorry. If you want to just call this pyruvate, I will not yell at you. Okay. Where does it happen? Cytoplasm of a cell. What does glucose get turned into? Pyruvate or pyruvic acid. Okay. Whether or not it has an H or an OH on it, just depends. Okay. You can call it pyruvic acid. You can call it pyruvate. I don't care. But glucose is a 6-carbon molecule, and pyruvate is a 3-carbon molecule. Okay. So we get 3 plus 3 is 6. That's math we can all get behind, right? So we get 2 3-carbon creatures. That is the end goal of glycolysis, to convert glucose into pyruvate. There are a number of steps, and I think I have them listed out here in a little bit. Okay. Am I going to ask you to give me the name of every intermediate? No, I am not. That's biochem class. This is not biochem. All right. But where does it occur? What enters? What do you get out of it? Those are great questions to ask on an exam. Aside from 2 molecules of pyruvate, okay, you get a couple molecules of NADH. Pyruvate just goes to the next step. To next step. Okay. So it's going to go to the transition reaction. Those NADHs, where do those go? To the electron transport chain. What else do I get? 2 net ATP. I need a little bit of investment to get glycolysis to ultimately work. Okay. I have to get glucose reactive. I do that by adding a couple phosphates to it. So I phosphorylate this thing. Okay. If I go over here, I'm just adding some phosphates to it. So glucose to glucose 6-phosphate to fructose 6-phosphate to fructose 1,6-bisphosphate. All I'm doing is adding a phosphate to that glucose molecule. That makes it very reactive, and that makes it very easy ultimately to split into 2 3-carbon creatures. Pyruvate, ultimately. Whether or not you know all the intermediates, I don't really care. I'm not going to ask. Okay. Glycolysis, where does it occur? Cytoplasm. What enters this pathway? Glucose. I mean, it's in its damn name. Glyco is glucose. Lysis means to break. We're breaking down glucose. Yes, we are. What do I get out of it? 2 net ATP. And let me go back here. 2 net ATP. 2 NADHs. And 2 pyruvates. Again, like I said, transition reaction is where those go. TRANSITIONRXN. Transition reaction. NADHs are where those go. Like I said a second ago, electron transport chain. ATP to the system of the cell. 2 ATP will allow the cell to do more work. Okay. Again, is 2 ATP a whole hell of a lot of work? No. Okay. No. Is it some? Yes. So can it do a little bit of work? Yes. It can maintain some contraction, some activity of that cell. Again, not a whole hell of a lot of activity, but you can still do some. To put in perspective, just to get up out of your chair and walk across a room, that just takes a few units of ATP. Okay. And lactic acid provides those, the first 3 seconds are that pathway. And then glycolysis can provide, maybe 15, 20 seconds worth of energy to walk across the room. Okay. That doesn't sound like a whole hell of a lot of work. And it's not. Okay. But by the time you get to 15 seconds, you've increased your rate of breathing. Okay. Getting oxygen faster in, pushing that blood faster through the system, getting that oxygen quicker to the muscles that need it. So by the time 15, 20, 30 seconds is up, your aerobic pathway is kicked in, and now you're providing 32 units of energy. Okay. If you're using glucose predominantly. If I don't have oxygen available, right, where this is anaerobic pathway, if I do not have oxygen available, those NADHs don't really go anywhere. Okay. I need oxygen to knock on the door to get into the mitochondria. If there's no oxygen, the bouncer ain't letting nobody in. Okay. So those NADHs are like, I can't do anything. So it's going to add those hydrogen ions back to pyruvate. That results in the formation of lactic acid. Lactic acid cannot be utilized by the cell. Okay? We have to pump it out. And we'll talk about it here in a second, but we'll pump it out to the liver. Okay? And through magic, we'll convert it into glucose. Okay? So all of those pyruvate molecules and those NADH molecules that I just produced in glycolysis, if I don't have enough oxygen available to continue on the steps, it doesn't do anything. It doesn't go anywhere. Okay? NADHs can't go anywhere. So it's like, I don't want to be here. So it takes those hydrogen ions, puts them right back on pyruvate. That changes it, as you can kind of see from the chemical reaction right there. Converts pyruvate or pyruvic acid into lactic acid or lactate. Okay. Lactic acid is not ideal for cells. A little bit's okay. A massive accumulation of it, though, and that changes the pH of the cell, of the tissue. And the tissue doesn't like it accumulating. So it tries to shovel it out, tries to get rid of it. 2 ATP is only 2 ATP. So it can't keep up that activity. So then what do? Cells stop working. You stop. And you sit there and you bend over and start heave-hoeing some air into your lungs until you can get that oxygen debt settled. Get enough oxygen in, pump that lactic acid out, and then you can start doing work again. Okay. So this entire pathway for lactic acid yields a whopping 2 ATP.
Hey, Dr. Thornley.
Yes, sir.
I don't know if I missed it, but you said glycolysis can be standalone. Did you already go into that, or I know you briefly?
This is it. Okay.
Okay.
If I'm doing an anaerobic type of mechanism here, and here's my example. Here's my example down here. Okay. If you're exercising as hard as you can, okay, you can only go balls out for about a minute or two, depending upon your level of training. Okay. When you're putting forth 100% effort for a minute, okay, after that minute, you are not going to be able to get enough oxygen in. Okay.
Okay.
And when that happens, the only pathway that's happening is glycolysis and lactic acid pathway.
Okay.
Okay. Because in that type of situation, it is in an anaerobic state. Okay. And I'm not talking, because I mean, what's complete lack of oxygen? Death, right? If you've exercised really hard before, right? You've run in place or jumping jack really hard in place, right? Sprinted really long. Okay. And if you've done that before, if you've sprinted for 30 seconds, I mean, you slow down. You stop. Well, what's that doing? It's allowing you to get oxygen in. Okay. And we'll talk about some of the physiology involved with changing the pH balance of muscles, leading to this anaerobic state that we're talking about right here. If you're a yeast, this is all you do. But you're a blob sitting on your desk. Who cares? Red blood cells, they don't have any mitochondria. So that whopping 2 ATP, that's fantastic. Okay. So that's how red blood cells get enough energy to be able to hold on to oxygen and carbon dioxide. Okay. Because that's what it primarily does. It does some other things, like some bisphosphoglycerate. Helps to increase oxygen carry capacity. So it does a lot of fantastic things. Okay, but red blood cells don't do a lot of heavy lifting. So they don't require a whole heck of a lot of energy. So that anaerobic pathway, this lactic acid pathway, that's all they do.